In this lesson, we will be using the elimination method to solve simultaneous equations. Before we begin, we must label the equations for reference. Equation 1, equation 2. Next, we need to align the terms, the x terms together and the y terms together. The aim of the elimination method is to remove one of the unknowns, either x or y. To do that, we need to look out for a common term. We can see that the common term is y, and the sign of y is opposite in both equations. Hence, we need to add the equations to remove it. So we write equation 1 add to equation 2. Adding the x term will give us 3x. And adding the y terms will give us 0. We don't need to write it. So adding the right hand side, we have 6. And when we work it out, we have x equals 2. So after finding x, we need to find y. We need to choose the equation that will make our calculation easy. In this case, I chose to substitute x equals to 2 into the first equation, where the y term is positive. So I have 2 times the value of x plus y equals to 5. And that works out to be y equals to 1. So my solution is x is 2 and y is 1. In the next example, we have a common term that is the same sign. In this case here, you can see that the y terms have the same sign. So to remove it, we need to subtract one equation from another. Since the x term is bigger than the x term in the first equation is bigger than the x term in the second equation, I would take equation 1, subtract away equation 2 to remove y. Now I have 2x minus x will give us x, and minus y minus negative y will give us a plus y, which actually results in 0. So we don't need to worry about it. And on this side, we have 5 minus 1, which is 4. So once again, we substitute the result, x equals to 4, into one of the equation. Well, in this case here, it's easier to use the second equation into equation 2, which gives us 4 minus y equals to 1, which works out to be y equals to 3. And we will have to put out the solution as x is equals to 4 and y equals to 3. In the next example, we do not have a common term. So in the first case here, we have a x plus 6y equals to 5, and in the second equations is 4x plus 3y equals to 1. We examine the terms and see what we need to do to make a common term. Now, we could multiply throughout by 4 for the first equation so that we will have a 4x and that will be a common term. But 4 is a bigger number. It is better to multiply by a smaller number, and that is 2. So we multiply the equation 2 by 2. So multiplying the equation 2 by 2 will give us 8x plus 6y equals 2. And this is labeled as the third equation. And now we are looking at the first and the third equation. And in this case, again, we have the common term, which is 6y, has the same sign. So we subtract to remove it. Now, since we have a bigger term in x in the equation 3, therefore we take equation 3, subtract equation 1. So we have 8x minus x to give us 7x. And obviously, the common term disappear. And we have 2 minus 5, which is minus 3. And x is negative 3 over 7. So we need to substitute. Again, we choose the equation that is better, is into equation 2. So we have equation 2 4 times. It actually does not matter which equation you substitute in. Alright? And then we work it out. Okay, in the next example, we do not have a common term in x or a common term in y. So in this particular case, it is necessary to change both equations to create a common term. When we examine the equations, we see that the x terms has a bigger number and the y terms have a smaller number. In this case, it's easier to make the y term the common term. To do that, we simply take the LCM of the two numbers, which is 20, and we need to create a common term in 20y for both. So for the first equation, we need to multiply equation 1 by 5. So this gives us 35x plus 20y equals to 10. And we call this equation 3. And we multiply equation 2 by 4. So 8 times 4 is 32x plus 20y, that is what we want, equals to multiply this by 4, so it's equal to 4. And we call this equation 4. So now, let us examine the equation. Look at the common term, same sign, and this is the bigger term in x, so we take equation 3, subtract equation 4. And this gives us a 3x. The y will disappear, and here we have 10 minus 4 is 6. x equals to 2. And now we substitute to find the value of y into either equation. I can choose equation 1. Right, so equation 1 we have 7 bracket times 1 plus 4y equals to 2. I chose equation 1 because the numbers are smaller. Alright, but any equation will do. Next, we take a look at another example. In this case here, you can see that the equations do not come in the right order. You see that in the first equation, we have the x term, y term, and the number. And in the second equation, the y term came first. So in this case, we need to rearrange the equation so that we have the x terms together, followed by the y term, and then followed by the number. So we must always check for the arrangement and not forgetting to label our equations so that we can refer to it when we solve it. Okay, so what we do now is we rearrange the second equation. So we say from equation 2, we have negative 3x plus y equals to 8. And we call this equation 3. Right, now we are ready to examine the equation. Equation 1 and equation 3. What is the common term? Well, we could multiply by 5, but it will be better if we multiply the first equation by 3 because then we can add the equation to remove x. It's easier to add equations than to subtract equations because of the change of sign. So I would multiply the first equation by 3. So that will give us 3x plus, multiply by 3, we will have 15y, and multiply by 3, we have 48. That is equation 4. Right, now we can add the equations, equation 3 plus equation 4, the two modified equation, and that will give us negative 3x plus 3x will be 0. That is what we want. Okay, so add equation 3 and 4 will eliminate x, and here we have 16y equals to 56. Right, that gives us y is, well, 3.5, and we can use that to substitute into the second equation or into the first equation because it's easier. Alright, substitute y. You notice that in this case we found y first into the first equation. Right, so x plus 5 times 3.5 equals to 16, and we can find x. In the last example, we see that the equations can get very complicated. Like in this case here, the first equation is a fractional equation. So we need to simplify the equations before we can solve it. So in the first equation, we multiply throughout by the LCM, which is 6. Multiply equation 1 by 6. Now when we multiply the equation by 6 throughout, we will be able to cancel the denominator. So when we cancel the denominator, this will give us a 2x. 6 cancel with 3 is 2. 2 times x minus 6 cancel with 2 is 3 equals to 24. That is equation 3. And then for the second equation, right, we need to rearrange it. So we have from equation 2, we have 2x plus 3y equals to 1. Call it equation 4. Now examine the two equations. So we see that the common term is 2x, as well as common term is 3y. But it's easier to add the equations for the common term which is opposite in sign. So it is better to add. So adding it, we have 4x, 2x plus 2x, and this will disappear, minus 3y plus 3y. And on this side, 24 plus 1 is 25. And we can work out the x value. And of course, the last part is to substitute what we found to find the value of y and specifying what is the solution. And this completes the lesson on doing simultaneous equations using the elimination method.